Welcome to EconTalk, part of the Library of Economics and Liberty. I'm your host, Russ Roberts of George Mason University and Stanford University's Hoover Institution. Our website is econtalk.org, where you can subscribe, find other episodes, comment on this podcast, and find links and other information related to today's conversation. Our email address is mail@econtalk.org. We'd love to hear from you. My guest today is Deborah M. Gordon, a professor of biological sciences at Stanford University. And our topic goes by different names: spontaneous order, complexity, emergence, self-organizing systems, the way that order emerges without control, the way that individuals can have very little knowledge, yet can act in concert as if the group had wisdom. Deborah is an expert on ants. She's the author of Ants at Work and the recent article in Nature, Control Without Hierarchy. And this phenomenon of emergent order is one of the central ideas in economics. So I wanted to learn more about ants, and I think Deborah has some interest in learning about what economists think about it, so I thought it might be interesting for you, the listener, to listen in on this conversation. Deborah, welcome to EconTalk.
Thank you.
I want to start with a quote from your book, Ants at Work. It's a really interesting book about ants, but has implications beyond ants. Here's the quote. "The basic mystery about ant colonies is that there is no management. A functioning organization with no one in charge is so unlike the way humans operate as to be virtually inconceivable. There's no central control. No insect issues commands to another or instructs it to do things in a certain way. No individual is aware of what must be done to complete any colony task. Each ant scratches and prods its way through the tiny world of its immediate surroundings. Ants meet each other, separate, go about their business. Somehow these small events create a pattern that drives the coordinated behavior of colonies." So to get us started, how did scientists come to recognize these patterns and this wisdom that the colony has? Give me a little bit of the history of how this puzzle began, how people started to find out about it, and what intrigued scientists originally.
Well, there's a bit of the Old Testament in Proverbs.
Yeah.
It says, "Look to the ant, thou sluggard." That's the part that people hear most. "Look to the ant, thou sluggard, consider her ways and be wise." But the part that's most interesting to me is that it goes on to say, "Without chief or ruler or overseer, she gathers her harvest in the fall to save for the winter." So somebody, 6,000 years ago understood that an ant colony operates without anybody in charge. And I always wonder, how did they figure that out? So I guess it's been known for a long time that there isn't anybody in charge. The ants, like honeybees, consist of mostly females. And all the ants that you see walking around are sterile female workers. And the ant that lays the eggs is called the queen. Naming that ant the queen, which has a suggestion of some kind of authority, some kind of
sovereignty.
Yes. That came about in the 18th century. So some of the French entomologists that were thinking about social insects gave that reproductive female the name of queen. And so actually the idea that somebody is in charge is newer than the idea and the reality that there is nobody in charge.
The queen is bigger.
The queen is bigger.
So that may be part of the reason. She looks like the leader.
Well, she looks bigger.
Yeah. Not the same thing, I guess.
No, not the same thing. But all she does is lay the egg. So she's really the ovaries of the whole colony rather than being the one who decides what needs to be done. It's really interesting to me in some of the recent movies like Ants and Bug's Life, the way that we set up the story of the ant colony with not just a queen, but generals and a bureaucracy, civil servants. It's very difficult for us to imagine an organization without a hierarchy. And I think that over time, if you look at the stories that people tell using ants, that what we see really is a reflection of the way that we think about how societies are organized and not about the ants at all. So as far as the ants go, I think it's been known for a long time that there's nobody in charge. Now, the question of how it works and how it's possible for ant colonies to accomplish so much and to be so successful ecologically without anybody in charge that's a question that I think has been more interesting over the last 20 years as we've understood that an organization without hierarchy is a really good way to make computers do things. And that's caused people to look back into the natural world for analogies in order to understand how nature has set up systems like that.
And so tell me, what do we know about ants in terms of their ability to use information that's available to a small part of the group and yet make that available, even though there's no example that I use when I talk about it is, they don't have cell phones. They can't
no
IM each other, and the queen isn't pulling in information and re-spreading it back out the way we think of a CEO, even though a CEO doesn't do that, but that's the way we sort of, as you say, imagine hierarchical organizations. But the queen isn't doing that. So what is going on, and how did we find out? Or what? Obviously, we don't know everything, I assume. There's still a little work left to do.
That's right. Well, there are 10,000 species of ants, and maybe 50 of them have been well studied. So everything we say about ants in general is probably not true. But given that qualification, then most ants can't see. So there are some ants that can distinguish shapes, but most ants can perceive something about the direction of light, but they can't make out particular forms.
How do we know that? They failed their
eye test?
I mean, how do we know that?
Well, yeah, they don't respond to any kind of visual stimulus, but they smell really well, and they smell with their antennae. So if you watch ants at all, you see ants touch antennae or touch each other's body with their antennae or touch the ground with their antennae. So when they touch something with their antennae, they're smelling it. And most ants operate mainly in a world of smell. And an ant has in its body many different glands, each of which secretes a different chemical, and they use those chemicals in communication. So most of their communication is through smell.
So within a species, do each type of ant in that species, worker, forager, do they all have the same glands? Or do they have different glands? Or do they produce different amounts depending on their task?
Within a colony, they all have the same glands. Within a species, yes, they all have the same glands. But they also use another kind of communication that's chemical, and that is not the short-term chemicals that are produced through the glands, like an alarm pheromone. So let's make a distinction between a chemical that an ant spurts out of its gland that means something right now, like an alarm signal. And many species of ants have this. When they smell that substance, they start running around in circles. So if you do something really nasty
like stamp
to ants, then they all start running around in circles. That's because some of them have secreted this alarm pheromone.
Now you said a pheromone. A pheromone is a chemical?
Pheromone is a chemical that's used, that's put outside the body, so distinguished from a hormone, that has some effect, and in ants, it's an effect of communication.
This is the equivalent of a spray.
Yes.
Or an aerosol, like an aerosol can. It's emitting they emit some kind of the substance that is sensed by the antennae, presumably.
That's right. And it's very volatile. It dissipates in the air really quickly. So those have short-term immediate effects. Mm-hmm. But ants, like all the other social insects, that's ants, bees, wasps, all in the same group of insects, they also secrete and spread on each other by grooming a layer basically of grease. They're fatty acids, so it's a very heavy grease. And that's secreted from a gland in their mouth parts, but they slather it on each other all the time, and it's thought that it helps the body keep from drying out. And these long-chain fatty acids, they're called hydrocarbons, and they're spread all over the cuticle or the outside skeleton of an ant. So keep in mind that an ant has a hard body. Those hydrocarbons on the cuticle carry a specific odor of the colony, and that's how an ant knows when it smells another ant if it belongs to the same colony or a different one. And that's also true in bees and wasps, that they have a colony-specific signature of their own smell that they spread on each other. And it's well known in ants that you can take ants in the younger stages before they become adults, and you can put them in a colony, not only another colony of the same species, but a colony of a completely different species, and they will be accepted as if they belong to the colony, and that's because they will come to take on the odor of the colony because it will be spread on them by grooming.
But there's some age, presumably, where it's too late.
That's right.
You
Once they're an
can't
adult,
fool.
it's too late.
Okay.
Yes.
But you can't fool them? You can't spread the other colony stuff on them and let them, and then transplant them into that colony?
We aren't very good at doing that, but there are cases where they seem to do that. Like
Spies.
there are what so-called slave-making ants that go and take ants of another species, and there seem to be situations in which an ant can take on the odor, but that's very rare. Mostly they go around slathered with this layer of goo that comes from their own colony, and that's how they know who belongs to my colony and who is different. And then we found in harvester ants, which is a species that I've studied for a long time, that within a colony, everybody has the same signature, the same colony-specific odor, but on top of that, ants of different tasks smell different. And that's not because they change what they produce as they do different jobs, but instead the conditions of the job make them smell different, especially the ones that work outside for a long time. So this is a species of ant that lives in the desert. They live throughout the deserts of the southwestern U.S. and down into Mexico. So they are outside in conditions where it's very hot and dry. And we've learned that the sun, so high temperatures and low humidity, change the chemistry of these hydrocarbons on their bodies, so that ants that have been outside for a long time searching for food come to smell different from the ants that are working inside the nest. And that means, as a consequence, that the ants that have been working outside, that one ant can recognize the task of the ant it meets.
Because its smell has been...
Because it smells...
It's the stuff its glands are producing, which has a distinctive odor, have been transformed by their task.
That's right. By the conditions of their task. So
like
I
a
like
coal
the
miner.
analogy, or analogy between that and the calluses on a carpenter's hand. So the calluses on the carpenter's hand don't make them a carpenter,
Right.
but they form because of the work that the carpenter does. And in the same way, because of the work that a forager ant does, it comes to smell different. So now we have found that ants use just the rate at which they smell each other, the rate at which they bump into each other to decide what to do. So the ants are going around doing their different tasks, and each ant has some rule like, okay, I'm a forager, I'm going to go out foraging again when I meet incoming foragers at a certain rate. And we figured out how the ant knows that the incoming ant is a forager by doing experiments where we extracted these hydrocarbons from ants and we put them on little glass beads, and we found that the ants would respond to a glass bead with the odor of a particular task as if it were meeting an ant, so that we could change the behavior of ants depending on the rate at which they meet little glass beads with a certain smell.
Before you continue, I just have to ask you a question, a little bizarre. Are these scents, these odors, perceivable by other species, such as a scientist? Can you smell it? Can you smell an ant? If you put an ant close to your nose, is any human being capable of sensing these distinctions?
Well, people can
A great wine taster, perhaps.
Yes. People can smell the volatile pheromones of some ants. So there is an ant in the tropics that has a distinctive smell of lemon because its alarm pheromone smells like lemon. So some of the volatile pheromones people can smell.
But these distinctions between foragers and workers?
No, the hydrocarbons are, it's a grease, it's not volatile, and no, we can't smell it.
Okay, so you dropped the glass beads, and you got, by dropping them more quickly, presumably, you were able to simulate a natural experiment of foragers returning to the colony, correct?
Yes.
Was that the experiment?
Well, the experiment used the smell not of foragers but of patrollers.
Okay.
So the way that things work in a harvester ant colony is they forage for seeds that are widely scattered around, not in nice, neat piles anywhere. And early in the morning, a group of ants that I call the patrollers goes out to scout around, and it's the safe return of the patrollers that tells the foragers it's okay to begin.
Okay.
So the foragers won't go out unless the patrollers come back. And mostly, I think what the patrollers are doing is checking that the ants next door of a colony nearby aren't using a particular area today. So if they meet the patrollers of a neighbor, they don't use that direction.
And why would they do that? Is there a risk of warfare, or just that there's going to be less productivity because you're competing with another colony?
They have a strange fighting season where they do fight, but they don't fight very often. So it's mostly just the competition.
It's not every Sunday in the fall for the fighting.
It's right after the rain.
Okay.
Yeah.
All right.
So it's mostly the competition, that if you're scrounging around for little bits of seeds in the sand and somebody else is scrounging around in the same place, then your chances of finding something are reduced. So
Now,
the patrollers go out and they come back, and when they come back, the foragers go out. And what we were able to do was to take away the patrollers, and if you just keep the patrollers in a box, the foragers won't go out. Because if the patrollers don't come back, it's not safe and they won't leave.
I'm confused about the patrollers, though. Let's say they encounter the other species in their pasture, their area or their factory.
Yeah.
What do they do? You say they don't go back? Do they just hang out? How do they? If the foragers don't go out till the patrollers come back, I don't understand what the patrollers do. Don't they always, after they've been out, they come back? Don't they always come back?
Well, if things are really bad, they might not come back. There's a predator, a horned lizard, that might eat them, and then they would never come back.
Right.
But which direction they come back from matters. So the colony is the nest is sitting out in the middle of the desert, and every colony has maybe 6 or 8 different directions it might go. And each day the patrollers choose a few. So if they go out in one direction and that's where they meet the neighbor over there, then they're not likely to designate that as today's direction.
Okay.
So it's not only whether they come back, but where they choose to mark. And we've recently found that they actually mark with another chemical from one of their glands the direction that the foragers will take. So if they go out in one direction and they meet a lot of patrollers from another colony, I think that they're less likely to choose that direction. I only know that because if you map the trails of neighboring colonies, you can see that if they meet one day, this is only the older ones, if they meet one day, they're not likely to use those trails the next. Actually, the adolescents are much more obnoxious, and if they meet the trails one day, they will actually go back and keep fighting and persist.
Yeah, that's par for the course. But after they've gone out and they've had an encounter that is going to be a bad thing to go overlap, do they go explore and find another?
Yes.
They try to find another quieter spot, come back on that route, and that signals to go out to that spot.
And then they mark that route.
Okay, so in the experiment, you were able to send out presumably the foragers to where you dropped the beads, as if you had simulated the patrollers returning.
No, we learned separately about what makes them go out and what direction they choose to go out. So, and we did it in that order.
Okay.
So first, we did experiments where and this is with a colleague, Mike Green, who is at the University of Colorado at Denver. The first thing we did was to take the patrollers away and put them in a box. So they never came back. So if you do that, the foragers just don't come out.
They just hang around.
Yeah, it's not okay to go out.
Play solitaire on their computer and
watch TV. Yeah. But
actually, what do they do?
I don't know.
Can you tell? Okay.
I don't know, because I can't see.
But they don't come out.
They don't come out. Then we took patrollers. Actually, of course, we had to do this in advance. We took patrollers and we have to kill them to extract the hydrocarbons off of them. Then we put their hydrocarbon, then we waited a week or two so they would recover from the loss of those patrollers. Then we put the hydrocarbons, the smell of patrollers, onto little glass beads. And we found that by dropping the glass beads into the entrance so that they went in, then the foragers would come out. And then we found that it had to be at a particular rate. So if it's too fast or too slow, it's not good enough. And,
so one straggler patroller who comes back the wrong way who gets lost or whatever, is not going to be enough to signal.
That's right.
Which is what you want.
That's right.
Which is brilliant.
And it seems that the ants can remember something for about 10 seconds. So the interval between patrollers coming back is about 10 seconds. And if it's too long, then it's as though they just forgot it ever happened and more patrollers have to come back. And if you look at what normally happens in the morning, the first few patrollers come out, they circle around, they don't go very far, they go back in. And then a few more come out. And so over time, there are more and more patrollers out, although overall, it's only about 30 to 50 patrollers, which signal to about 1,000 or 2,000 foragers that it's okay to go. So it's a very small number of ants regulating the behavior of a much larger number of ants, without, again, anybody deciding, okay, we're the patrollers, we're in charge, we're going to tell all those foragers what to do. But they go out, more and more of them go out until you hit maybe all 30 or 40 of them are out, and then they start coming back. So over time, the rate at which they're going back increases, and it is when it gets to be about one patroller returning every 10 seconds that the foragers start to emerge. And then we wondered, just the question you just asked, I had known that the patrollers must have something to do with the direction that they go, because I had noticed and then had measured and seen that more foragers go in the direction where there were more patrollers. So then we wondered, well, how do the foragers know what to do in response to the bees? So why don't they go out and mill around and act confused? And then we realized that they were doing that a little bit. They were sort of circling around. And then we did some experiments where we took away the patrollers, put in beads, and we marked foragers to see if they would go on the trail they did the day before. And they did that. In the absence of patrollers, they just go where they did the day before. Then we put down barriers on the mound that blocked off a certain direction. So we didn't let the patrollers use that part of the nest mound. And I should say that the nest mound is maybe a meter across, but the trails go for 20 meters. So we just kept them off one sector of the nest mound. And the foragers wouldn't go there if the patrollers didn't go there. And then we extracted some of the glands, and we found that if we marked a sector without patrollers, where the patrollers had been prevented from going, with the extract of one of the glands, which is called the Dufour's gland, then when we took away the barrier, the foragers would go there. So it looks like the mark of the patrollers overrides the memory of the forager. You see, if the forager doesn't get any instructions from the patrollers, it just goes where it went yesterday. And that's what was happening in our experiments. We were substituting for the real patrollers by putting in these beads. They meet something that smells like a patroller, they say, okay, it's good to go out, but then they go out and there's no instruction about where to go, so they just go where they went yesterday. But if the patroller has marked to go, if the patrollers collectively have marked to go somewhere else, then they go there.
Two questions. Do you feel guilty killing an ant?
Yes.
So it's an interesting, just as an aside, it fascinates me how we perceive animals in the animal world. What are called sometimes charismatic megafauna, which would be a deer and grizzly bear and things that we have. Whales, we have great romantic notions about. We don't have a lot of romance about ants. Most people don't. I'm sure, but though
most people are afraid of ants.
Most people are afraid, and they feel virtuous killing an ant. I don't. To me, they're all creatures have a certain level of holiness. I try to leave them to do their job unless they're going to hurt me. But you're doing science, so that must be hard.
Well, I have worked it out over the years so that I never have to kill any ants. So other people kill ants.
That's what graduate students are for. Interesting.
Right.
It's the same in every field.
Yes. I don't like to kill ants.
My other question, which is something I know I've heard about, and I'd like you to verify it and make sure I understand it correctly, is that the queen, although the queen is not the leader and has no instructional authority over any of these behaviors we're talking about, the queen does have control, not conscious control, obviously, but has control over the mix of types within the colony. And you mentioned earlier that there's a very small number of foragers, patrollers relative to foragers. Does that mix change? Does the birth rate change? For example, the reason I ask is that this is what I heard. I see you shaking your head that I'm wrong, so maybe I'm confused. But my understanding was that after a war, in some ant species, the queen is somehow able, through contact as people return from the war, to change the mix of fighters and workers versus, foragers and patrollers. Is there any? Have you heard of that? Am I crazy?
Well, no. In some species of ants, the workers as adults come in different sizes. So often the large ones are called soldiers and the small ones are thought to be regular workers. That's very few ant species actually have that, okay, where the ants come in different sizes. And it's not clear that the bigger ones actually are always soldiers or do something to do with fighting. Like in one very large group of ants, the large ones actually break seeds. So they have big jaws for breaking seeds, not for fighting. Uh-huh. But in most species of ants, all the ants are the same size. But I think the earlier idea was that even that ants were sort of born to do a task. And in the movie Ants, there's a bureaucrat who sort of,
it's a caste system.
Yeah, who just stamps the larva at birth. But in most species of ants and in honeybees, the ants change jobs.
Oh, okay.
So they do a different task. Their task changes as they get older. So the queen isn't making certain types. The queen is just making generic workers who go through a process that leads them to change tasks. And I found in harvester ants that when more ants are needed in a certain task, the ants will change. It's a one-way flow.
My question is this is a key classic example in economics of the division of labor, right?
Yes.
You have people doing different tasks in the modern economy. In a modern economy that's not controlled from up top in a hierarchical way, as a communist system, say, or an authoritarian system, that's regulated implicitly. It's self-organized by wage rates and other factors. How does the ant colony reassign folks to tasks as they're needed?
Well, that's the process that I work on, and I call that task allocation. Mm-hmm. And so that's a process that has to be driven by very simple rules at the level of each ant, which add up to predictable trends in how ants would switch tasks if they're needed. So I find that there is a sequence that an ant will go through. Early on, it works mostly inside the nest, constructing tunnels, but comes out of the nest to take bits of dried up soil out, basically to carry things out. Then it could become a patroller and then a forager. So an ant that's working inside the nest doing what I call nest maintenance work, if more patrollers are needed, so I do an experiment where I create conditions where more patrollers are needed, the nest maintenance workers will switch to patrol. And if I do an experiment that creates conditions where more foragers are needed, the nest maintenance workers will switch to patrol, and the nest maintenance workers will switch to forage if more foragers are needed. The patrollers will switch to forage if more foragers are needed. But if I do something that creates a need for more nest maintenance workers, they have to be recruited from the younger ones inside the nest.
So it's a slower response.
Well, it's a one-way response because nobody who has passed out of nest maintenance will ever switch back. The patrollers won't go back in to do nest maintenance. The foragers won't go back to do nest maintenance. So the foragers act as a kind of a sink, and the younger ants inside the nest are the source, and they are recruited up, which makes sense in an environment where food is limiting. And if ever there is an opportunity to collect more food, the colony has to take advantage of it. So no ant is saying, okay, we need more foragers over there. But because they have a series of simple rules that direct the flow towards foraging, the outcome for the whole colony is that when more foragers are needed, they get them.
What is that simple rule?
Well, if the rate at which I'm meeting foragers really increases, the rate at which I'm meeting successful foragers really increases, I'm going there too.
Right. That's so interesting.
I don't know if you call that division of labor. That's something that we and among people who work on social insects have gone round and round about. Everybody wants to call that division of labor, but I don't think that's what Adam Smith was talking about.
Why?
Well, because Adam Smith, as I understand it, was portraying a happy village where everybody does something different and they each give each other the products of their work. Mm-hmm. And in that way, the whole community can thrive because everybody is doing what they do best and what they like to do and so on, and everybody is happy. This is a system in the ant colony where there isn't any evidence that anybody gets better at it by doing it, but instead some set of transitions which is imposed from the outside relative to any particular individual determines what the trends will be.
Yeah, it's not much different actually in economics. It is related to the division of labor, and I understand why you would think it's not. But I think it is. Let me try to give you the idea of it. When we talk about specialization, which is one piece of this story, we tend to think of learning by doing. That when you specialize, mm-hmm. you do a task over and over and you get better and better at it. There's some truth to that, obviously. In some activities, that's extremely important. Anybody who's done any change jobs realizes that it takes a while to get good at the job, even if it's as minimal a thing as finding out where the soda machine is and where the best place is to have lunch nearby. There's a whole bunch of specific knowledge that workers have about their environment around them, some of which are directly related to the task, obviously, and some are not as directly related. But on the flip side, you do the same thing over and over again, you can get bored. It can be monotonous. So to me, there's a tension in specialization, especially historically, where workers were in manufacturing doing tedious things over and over again. Mm-hmm. You and I specialize. You're extremely specialized. You're not just in the biological sciences. You're not just in ants. You're in harvester ants. But you're not bored. There are some tedious parts to your job, but in general, it's not tedious. It's not like Charlie Chaplin in modern times working on an assembly line. So in modern times, especially, ironically, to use the phrase that Chaplin used, specialization isn't particularly tedious. There is a learning by doing aspect, but the real power of specialization, in my view of it, comes from getting the right people in the job, because we're not all equally good at doing X, Y, or Z. Yes. And so that's not so relevant for the ants either. But in the human world, what's going on is that changes in wages and non-monetary compensation and non-monetary satisfaction that people get from various tasks, when those change, that draws people into that task. Now, when NBA salaries go up, I might like to switch from academic life to be an NBA player, but I don't have the skills. A random assignment of people into that. It's not just we want more people in the NBA, we want more skilled people in the NBA, and I'm a very bad substitute for an NBA. For those of you listening at home, I'm 5'6", so maybe 5'7" on a good day. So obviously my productivity in that job is not the same as Larry Bird's or LeBron James. So in economic activity, the power of specialization is this idea that people are doing one thing really well, but it's who's doing it well. It's not just that, I'd get better at basketball if I did it full time. I'd never be good enough to match the skills of the current crop. So in economics, specialization comes from assigning people, and again, I want to come back to this question of language in a minute. I said assigning people. That implies that there's somebody, that verb assigning implicitly implies someone's got a clipboard and is telling people where to go. Nobody's assigning anybody, but wages and non-monetary compensation and returns and pleasure are drawing people into certain tasks, and that is expanding the output of the entire society without anyone's intention. Similarly, in the ant world, when the demand for, to use economic language, for foragers goes up because of, say, a more attractive food source, the ant colony wants to, if it had sentience, which it doesn't, but if it had consciousness, it would be good for the colony to expand that. And set of signals go forth, just like wage rates, to draw people into that. Now, the difference is that probably it doesn't get the best people into foraging. To take my basketball example, right? It pulls just a certain number. It's all that matters, right? I assume they're all pretty much equally good at foraging, or...
Well, it's what we call what's called in computer science a distributed process, where we think that it works pretty much as though everybody is equal. So not just that they're equally good at it, but also that their desire to do it is equal, and so on. Now we know that there actually are differences among ants, and some of them seem to work harder than others.
None of them are sluggards, but...
Well, no, actually quite a lot of them are sluggards, So in the harvester ants, it looks like at any time about half the colony is just hanging around doing nothing. And that's a pretty interesting question about why the colony works like that. But if we think of it as a distributed process where an ant isn't born dedicated to anything or better at anything or likes anything more than anything else, then it seems that that's a reasonable way to understand how it works.
And we'll just come back to the economics. An example I think I've mentioned in a podcast before, maybe on our divisional labor podcast, but a very interesting distinction between Adam Smith and David Ricardo and how they looked at specialization. So in Ricardo, the idea of comparative advantage is that people have different skills. And our interactions with each other are driven by those differences. So if you're good at farming and I'm good at raising sheep, I'll swap my wool for your grain. And obviously, if I'm really good at shepherding and you're really good at farming, we want you to be the farmer and we want me to be the shepherd, and that happens naturally through divisional labor and then trade that results from our differences. So Ricardo's story of where trade originates and where specialization originates, and the power of specialization comes from the fact that we're different. But Adam Smith understood something, and maybe this is what you're thinking about, or maybe it's the opposite, I've lost the train of thought, but what Adam Smith was really talking about when he said the division of labor is limited by the extent of the market. And the example that Jim Buchanan, my colleague at George Mason, uses is that if you have a bunch of people who hunt and they go out into the forest every morning to, like your foragers, they go out to try to find game. As the number of hunters, and each one makes a lunch before they head out or some kind of provisions while they're for their day out in the field. Well, once you get enough hunters, one of the hunters, let's say you have 100, the 101st has a choice, as they all had before, as they all have now, between being the 101st hunter and between opening up a deli. And that deli is going to supply all the hunters with sandwiches for the day, make it more effective than having to each one make their own, because the deli can exploit the fact that they're making 100. They can buy in bulk. They can automate the process, perhaps. So Buchanan's insight about Smith, which is fascinating to economists, I don't know if it's interesting to you, but the idea is that 101st hunter, they could all be equally skilled at hunting and equally skilled at running a deli. Mm-hmm. But once you get 100, the 101st one can make a living with the deli. So what Smith's insight is you can get specialization not because people are different, but just because the opportunities get large enough for specialization when there's enough economic activity going on. And that's what he meant by the division of labor is limited by the extent of the market.
So then it isn't any special characteristic of the 101st person?
Not in Smith's story, but of course in the real world, people differ in their ability to run a deli versus be a hunter. And as we said, there are differences. Even 100 hunters aren't going to have the same skills. Some are going to be better than others. You'd presume, and here's where Ricardo comes in, that if there was a relatively bad hunter, he would choose to be the deli maker. Or, and this is the deep insight of Ricardo, even the best hunter might run the deli if he's so extraordinary at the Earl of Sandwich would be the guy you'd want running the deli, even if he was a great hunter. And Ricardo's insight, which is the unintuitive, one of the few unintuitive things we teach our students, is that you wouldn't just naturally test people on hunting and say, well, the worst one becomes the deli runner. It might be that the best one. And his insight, Ricardo's deep insight was, it's the relative productivity and costs of these tasks for each person, not the absolute. Right. So Smith was emphasizing, they work together, they're not mutually exclusive, but they cause you to focus on different intuitive parts of the story. So in that way, you learn something that's missing from each one. Now, I want to come back to a point you make I think in the Nature article that I mentioned earlier, Control Without Hierarchy. Is that the name of the article?
Yes.
I think. This self-organizing system without a leader, without a queen, as the traditional sense of the word queen, is imperfect. It's remarkable how well it works given that it's not controlled, that there's no centralized intelligence, but it, of course, is imperfect. And you give the example, I think in the article, maybe it's another one, where you talk about a big pile of seeds. If it's in the one place or another, they can miss it because they're in these...
Yes.
Talk about that. What happens?
Well, this is true of any kind of ant, that if there's a big pile of seeds out there somewhere in the world, a jackpot, winning the lottery, they could miss it because they only go to certain places. But of course, they operate in a world that doesn't do that. In their world, lots of little bits of crud get scattered around all the time, and they just have to find enough to keep going.
Presumably, if the world did work the other way, they might have figured out a way to find piles more higher probability, I guess.
Yes.
But when you do the experiment,
yeah.
When you do the experiment, they don't always find it, or they rarely find it. Is that what happens?
Well, if you put out big piles of seeds, it actually goes back to what we were talking about the patrollers. If the patrollers don't find it, the foragers will ignore it, and they will actually walk over a huge pile of seeds to go to the place where the patrollers told them to go.
Wow.
So if you put it out too late, after the patrollers have gone back in, they will just walk right past it because they're set for the day. And we've found since then...
you say past it and over, you mean literally climb over the pile?
Yes.
Now, we got to stop here. I got to ask a clarifying question and then a puzzle question. You said the trails can be up to 20 meters long.
Yes.
How long does it take an ant to cover 20 meters, roughly? Is that a 10-minute experience or a 3-hour trip?
It's about 25 minutes on average.
Not long. So they don't go out very far in terms of time.
And what we found recently, this isn't published yet, is that each ant goes back to the same place on successive trips, and that helps for me to explain how they end up walking over the seeds. So an ant goes out...
Just to clarify, the forager, the patroller tells them a direction, but obviously they don't signal how far to go.
That's right.
So and how far is determined where they went the day before, evidently, or usually, or...
I don't know about the day-to-day transition, but within a day, a forager makes many trips. So they may forage, the colony may forage for 3 or 4 hours, but each trip takes on average 20 minutes. So each forager is going in and out, and which direction, whether it goes out at all, depends on whether the patrollers come back. Which direction it goes depends on which direction the patrollers marked. But where it goes once it gets out, it looks as though the distribution of places where the foragers find food is pretty random. So foragers go out in a certain direction and they go out a certain distance, they start searching around, they find food, they come back, and they wait inside the nest, and then the rate at which successful foragers come in determines whether they go out again. Then once they go out, they go back to more or less the same place. Each forager goes out to more or less the same place. So if you imagine once the whole thing has gotten started, everybody's going back and forth to pretty much the same place, and those places are distributed maybe up to 20 meters from the nest.
And presumably they're related to where seeds are likely to be found because of this.
Well,
what kind of seeds are these?
Grass seeds. They're mostly scattered by wind and flooding rather than dropping directly from plants. And a lot of them are buried in the soil, so they have to use their amazing powers of smell, again, to find seeds in the sand.
Does every forager, when returning to the nest, bring back a seed?
Pretty much. So they stay out there searching until they find something. And that's the beauty of a system where the rate at which they go out again depends on how quickly they're coming back. Because if everybody's coming back very slowly, it means there isn't very much food out there. So that's how the rate at which they forage is tuned to the availability of food. And yet nobody is coming back and saying, well, today is a pretty good day. It's just that if they take a long time out there, they come back slowly, and then they go out slowly, and the whole thing slows down. Whereas if there's a lot of food out there, everybody comes back quickly because they find food quickly, and more go out. so that the intensity of foraging goes up.
What's the cost of foraging in the economic sense? You say they don't
Drying
go out
out.
as fast, so there must be something they're trading off there. What is it?
Yeah.
Drying
good,
out?
Yeah, good economic question.
Yeah.
The cost is desiccation. So they
Yow!
yeah, well, they get their water mostly from metabolizing the water out of the fats in the seeds that they eat, but they spend water just being out in the sun looking. So they're basically using water to get water. And at some point, it's not worth it. At some point, the amount of food out there is not worth the water that it costs to get it.
Do they respond to outdoor temperature as a
Yes.
result?
Yes.
As well as the rate of patrollers and foragers returning?
Yeah, well, all insects, don't control their own body temperature. And basically, the hotter it is outside, the hotter they get, and the faster they move. So they can't move very fast at all when it's cold, and when it's really hot, they start running around. But when it reaches a threshold temperature where just the heat on their little feet is unbearable, then they don't go out at all.
Just like us.
Yeah, yeah,
But they don't have sweat. They don't have the ability to sweat.
No.
So they're stuck
they're stuck.
using these other again imperfect mechanisms. So they'll walk over the pile of seeds, which is not the best system, right?
No.
Maybe, but that's just the way they've got it.
Yeah.
So to sort of summarize here, the colony acts as if it's wise, even though there is no wise member of the colony. Very similar to some of the ideas in James Surowiecki's book, The Wisdom of Crowds, very similar to Adam Smith's The Invisible Hand and Hayek's Use of Knowledge in Society. Do you have trouble with language doing that? You probably don't worry about it. I worry about it. I'll tell you why in a minute. But do you use the colony as the subject of a sentence? The colony found a new food supply, right? There's no real language in English, or maybe in any language, to describe a verb in this self-organizing kind of model.
Yeah, it's a problem. Yeah.
Do you ever think about it?
I think about it all the time, and I do think about colonies as individuals. They're the ones that it's the colonies that reproduce. Ants don't make more ants, but colonies make more colonies, and so in the biological sense, colonies really are individuals. But as far as how we talk about it moment to moment, it's easy to fall into talking about the ants as if they have agency. That ant wants to get that seed.
Right.
That ant's trying to do this. And it's very hard to talk about a colony that way, because when you look at a colony, what you see is a lot of ants. But that's what I like about it, is that tension between what you see ants doing and what is really happening, which is the coordinated behavior of the whole colony.
Yeah, well, Friedrich Hayek, in his article, The Use of Knowledge in Society, called the human version of this a marvel. And it is the marvelousness of coordinated behavior without a coordinator that makes what we do interesting and wondrous and marvelous, as Hayek called it. It is fascinating.
Yes, but with us, for me, the problem with the analogy between humans and ants is that it matters so much to us what we think we're doing. Even if we're deluded, it makes a big difference how we understand what's happening to us.
It does, but let me talk for a minute about the part that is the same, where it doesn't matter. And it's, I'm actually struggling right now thinking about how important it is that we have consciousness, that we have agency, or we think we do at least. We appear to. So to take the example of iPencil, which Leonard Reed talks about, which is really an adaptation of the ideas in the article by Hayek I mentioned. Let's suppose a piece of a pencil, the graphite, becomes in higher demand by someone else who doesn't make pencils, but who does something else entirely different. Graphite's used in fishing rods, it's used in tennis rackets, it's used in brake linings of cars. So let's suppose there's an increase in demand for cars somewhere in the world. Might be in the United States, might not be. But as a result, graphite is now less available to the non-car manufacturers, the pencil makers, and the tennis racket folks. So how does that awareness of the demand for cars get the other players in this graphite market to cut back? There's two possibilities. They could cut back, or we could expand the supply of graphite to accommodate this increased demand by the car makers. Now, that's a very difficult question to answer just to start with. Which of those two things should we do? Should we expand graphite supply, or should we get tennis racket makers and pencil makers to cut back? And of course, if we say they should cut back, we can think of a whole myriad of ways they could cut back. They could cut back by just selling fewer pencils, making fewer tennis rackets, or they could try to find a substitute, or they could find a productive process that uses graphite, requires less graphite. They could change the mix of graphite and mud, which is used in water, which is used to make the lead of a pencil. You start thinking about it, and very quickly you realize that the range of choices that we have for how to respond to this crisis, akin to a food supply in your ant colony changing, or someone stepping on the colony and requiring some set of repairs, the set of choices we have are so vast. And you start thinking about what knowledge would we want to have that someone, if they had the control over the process, what knowledge would we want them to have to process to make the right decision? Well, you start thinking about that, and the range of knowledge, and this is what Hayek was focusing on, is unfathomably large and doesn't exist until the crisis occurs. It's not knowledge that we think of that's in a book you can look up and say, well, let's see, how good are tennis makers at finding new ways to make tennis rackets? Or how good are tennis players able to go without a racket or not have a second racket? I mean, there's such an enormous range of human possibility. When you start thinking about it, you realize, well, there's no way that a central authority, even with the greatest computers in the world, could acquire and process that information and then resend the decisions back out to the decision people who would use that information in a way that would be useful before something else changed, because it's actually change going on all the time in the economy. It's not just cars. There's a fad about whether to play golf instead of tennis or tennis instead of golf. There's people inventing ballpoint pens. There's a million things changing that touch on the graphite market. But the graphite maker, the graphite supplier, and the tennis maker, tennis racket manufacturer, and the pencil maker, they just look at one thing. They just look at the price of graphite. And as soon as the price of graphite goes up, which it will start to do as the demand for cars pushes up the demand for graphite, that sets in motion, just like your pheromones, just like your the hydrocarbons, a whole set of responses on the part of tennis racket makers, pencil makers, graphite miners, the people who are pulling graphite out of the ground. And if the response is inadequate, and there's a mismatch between how much graphite is being produced and how much people want to use as producers, the price goes up higher or it goes down. And so it's a self-regulating mechanism. It is imperfect. The price can change in ways that aren't ideal. People can not notice things that are opportunities, but that it works at all and actually probably works better than a centralized system is one of the great miracles of our understanding of human society. One more point, then I want you to hear your reaction. The difference between, and so my claim is that each of us as economic actors is very much like the ant. We have our little task. We try to do it well. We respond to the incentives around us. Sometimes we mess up all kinds of ways, out of ignorance, irrationality, passion, for all kinds of reasons. But overall, there's an immense amount of order in our society. And the simplest way to think about it is that just the general availability of goods in the face of these shifting changes. So, but unlike the ants, we have sentience, we have intelligence. We can try to respond in ways that are not just programmed into us via instinct, but we can come up with whole new ways to make graphite, whole new ways to make tennis rackets and fishing rods and brake linings, which gives us a dynamic aspect to our society that ant colonies don't have. To me, that's the main difference.
Well, the ants aren't faced with the decision about whether we care more about pencils or tennis rackets. They only keep going. If somebody steps on the ants, the rest of them just keep going. but
Why do you say that?
In your story, you're taking for granted that the goals are just taken for granted. Like we want everybody to make all the different things that people make. But we could also think about whether one thing was more important than another, or if we wanted to sacrifice something, or if we wanted to encourage something, or so we have values.
Who's we?
I don't know. Well, we don't have we don't have a system like that, and as you say, it's impossible to imagine how that would actually work. But there's still a whole set of values about all of the different products that we make.
Sure.
That,
well, I think those are in there. Let me take a shot at that and see what you think. When I said who's we, I was being a little facetious. We is all of us. But what I wanted to emphasize when I asked that rhetorical question was we usually don't have a unanimous desire for what should be done next. I have my tastes and preferences and desires and goals and dreams, and you have yours. They sometimes coincide, but they may not. In fact, often they don't. Often there's tension over all these things, and prices play a role in keeping those tensions from becoming from becoming violent, actually, when tied to property rights and other mechanisms of institutional arrangements. But let's think about the value point. Let's suppose that a bunch of us decide, which is what's happened over the last 25 years in America, certainly, and probably around the world, that I don't want to eat meat. I want to be vegetarian. I want to stop eating meat. Now, we could imagine a world in an authoritarian control, top-down systems. This didn't literally happen, but we could imagine it happening. We could imagine a world where the people in charge of the whole system, I want to make it clear that when you talk in your book, as I quote at the beginning of this podcast, that human organizations have control. Human organizations have control, but there's very little control across organizations. Mm-hmm. So that's the distinction that Hayek, for example, and Adam Smith and others are talking about. So if we could imagine going out, the person in this, where there's a person literally at the top, that person would go out and survey people and say, well, how are your food habits? Do you want to do anything differently next year? You happy with the mix of stuff available in the store? And you might be able to answer that question. You might not be able to. But it's possible you could make plans based on the answers that people give. And my suggestion is that if in that system a bunch of people said, oh, I'm thinking of vegetarianism, you'd have an interesting challenge of how to then change the products you'd want to make for the vegetarians. First, you'd have to decide how many products you'd have. Would you just would you just say, well, we're not going to have as much beef and chicken production, and that'll free up land and feed for other things? Oh, I wonder what we'll do with that. We have a whole set of, it's going to set in motion a whole set of stuff. The market solution, and the language problem that we have in economics is we often say, well, the market will do X, when in fact that's a meaningless statement. The market doesn't do anything. It emerges through these individual decisions, which again, we don't have any language for. We have roundabout ways of describing it that are very ineffective and frustrating. So we often just say, well, the market does this, as if the market is a sentient actor, something with agency and consciousness, which of course it doesn't. In one sense, that's harmless. It's just a shorthand that economists use. On the other hand, it frustrates and hampers the ability of others, including economists often, to understand what is really going on. After all, they start thinking that the market is a black box that just solves problems. Sometimes it does, sometimes it doesn't. It totally keeps you from understanding the underlying stuff. But I want to come back to your question. I apologize for rambling here. So in the market system, in this disorganized, I like to call it non-organized, because it's not disorganized, it's non-organized. In that market system, when people become vegetarians, because they value vegetarianism more than they value being a carnivore, a bunch of stuff gets made for them. A bunch of stuff gets set in motion through the incentives, these simple signals that you were talking about within the ant colony, that causes vegetarian burgers to start getting produced and vegetarian sausages, and restaurants to start offering vegetarian options, and vegetarian restaurants to open. A huge set of stuff gets put in motion. And if you said, well, it's going to happen, don't worry, you want to be a vegetarian in 20 years, I think you'll have some more options. takes about 6 months, 3 months sometimes, for some of these social trends and desires of people to have available choices. And those choices don't hamper the choices that other people make. Now, they do hamper them in a sense. A lot of times it'll mean that something else that people like is going to change its price, and they're going to have to pay a higher price for something as a result of this. But it works pretty smoothly. And it's amazing that the choices available to other people are still often out there, despite these dramatic social trends. So that's the sense in which you're right, we do care. But I think what you're maybe referring to is that you might care about other people's choices, not just your own. And you might not like the fact that there are other people eating meat and that the system caters to their meat eating if you're a vegetarian, or vice versa. Is that what you had in mind? That we might have tastes and preferences over global outcomes. The way the town center looks when Walmart builds a big box on the edge of town.
No, I was thinking of your original example in which you have a conflict between the tastes of different people, the graphite manufacturer and so on, that for the ants, if that happens, there is no possibility of it having any impact. But for us, we have the option of making a decision about how to resolve that. We may not make any such decision, and it's hard to see how to implement such a decision, but we are different from ants in that we can be sitting here talking about it.
Right.
And so it seems like that could make a difference. Well, also, we know about the extended effects. I mean, if lots of Americans decide to become vegetarians, it affects the extent of tropical forests in Malaysia. So, and we're capable of knowing about that and thinking about what that means. So, I have to hope that makes some difference.
Oh, it does. It does. And in fact...
And that's some sort of crucial distinction between the way that we work and the way that ants work. That is, I think that there are sort of forces generated by the type of system that ants operate in, and that there are analogies to human economic systems, and that some things have to happen the way they do because the system works that way. But it seems to me that in a human system, on top of that is the fact that we can understand it, and we could, in principle, make decisions about changing it, and that is a huge difference.
Oh, I totally agree. And in fact, it brings me to one of, I think, the key lessons of self-organizing behavior in economic systems, which is the following. There are many self-organizing systems that don't work well from our perspective. They're not just the way, like you say, for the ants, that's the way it is. There's nothing that can be done about it. They don't have any idea that something can be done about it. For us, when we see self-organizing systems that produce bad outcomes, we want to fix them. Two classic examples would be pollution or traffic, right? These are examples where our individual behavior, what's acting in our own self-interest, the invisible hand, leads to outcomes that we all agree would be better if they were different. And so we have a natural tendency to say, well, we can fix that. Ironically, because we don't have a lot of intuition about self-organizing behavior, we often look for solutions that lead to unintended consequences because we don't understand the nature of system-wide change. So we widen the 101, the big throughway here in the Bay Area, and we can't understand why a year or two later it's just as crowded as it was before. We made the road wider. Yeah. And it's because we have so
we didn't look at ants enough.
Yeah, exactly. Yeah. So I think that's maybe a nice place to stop. We ought to look more at ants and more at the human analog to ants. Again, I didn't mean to suggest that we're all ants literally. This ability to intervene and choose different outcomes is extremely important. And the role of the political process in processing our political desires and the opportunity for unintended consequences, as well as the advancement of self-interest under the guise of improving things for others, is, I think, what we call public choice in economics, and is a very, very fascinating and important subject. But what I wanted to focus on is that there's a part of us that is ant-like, and I think we'd be better off if we understood it.
I agree.
My guest today has been Deborah M. Gordon of Stanford University. She's the author of Ants at Work and many other fascinating works on ant behavior. And thanks for joining us.
Thanks very much.
This is EconTalk, part of the Library of Economics and Liberty. For more EconTalk, go to econtalk.org, where you can also comment on today's podcast and find links and readings related to today's conversation. The sound engineer for EconTalk is Rich Goyette. I'm your host, Russ Roberts. Thanks for listening. Talk to you on Monday.